Hello students, welcome back to my channel. Today we will study the topics of ring theory, that is embedding theorems. In that we will study that a ring can be embedded into R cross Z and therefore any ring can be embedded into the ring of unity, ring with unity. Now let's get started. Now in embedding of rings, a non-empty subset S of a ring R is called a subring of R if S forms a ring under same operations as R. Therefore, a subring inherits its compositions from the parent ring that is R. अब इसी प्रोसेस को हल्का सा रिवर्स करना हो, that is given a ring S, we have to find a super ring so that S is a subring of R. So it is not always possible, but we can say it like this, that we have a ring R so that our S is isomorphic to a subring of R. Then we can say that we can identify S as a subring of R. This is what we call embedding of rings, where we have a ring R such that S is isomorphic to a subring of R. Then we can identify S as a subring of R. Now, let R and R dash be two rings. A 1-1 homomorphism phi from R to R dash is called embedding or embedding mapping, and in that case R dash is called extension ring or overring of R. Now let R be any ring and Z be ring of integers. Consider R cross Z equal to R comma N, where R belongs to capital R and N belongs to integer. We will now show that R cross Z is a ring with unity under addition and multiplication defined by R comma N plus S comma M is equal to R plus S, N plus M. R and S belongs to capital R, N and M belongs to integers. Similarly, multiplication is defined in a unique way, that is RS plus NS plus MR into NM. ये हमारे पास रिंग के एलिमेंट्स हैं, क्योंकि कॉम्पोजिशन ऑफ रिंग के मल्टीपल n टाइम्स, रिंग के एलिमेंट का मल्टीपल m टाइम्स, so it whole belongs to R and this belongs to integer, therefore it is well defined. ताकि देखने के लिए कि हाउ इज इट वेल डिफाइंड. Addition is well defined is easy to show, so I will show you that multiplication is well defined. For that, what we need, let r comma n is equal to r dash comma n dash, and s comma m is equal to s dash comma m dash, which in turn implies r is equal to r dash, n is equal to n dash, and s is equal to s dash, and m is equal to m dash, which in turn implies rs plus ns plus mr is equal to r dash s dash n dash s dash plus m dash r dash, and similarly nm is equal to n dash m dash, and therefore rs plus ns plus mr comma nm is equal to r dash s dash plus n dash s dash plus m dash r dash comma n dash m dash. Hence multiplication is well defined. Associativity, r n plus s by m plus t comma k is equal to r comma n plus s plus t m plus k, which in turn is equal to r plus s plus t n plus m plus k. अब R is a ring, तो R के elements associativity follow करते हैं under addition, which in turn implies R plus S plus T n plus M. Integers is also a ring, so associativity is followed. R plus S comma n plus M plus T comma K, which in turn is equal to R comma N plus S comma M plus T comma K for all Rn comma Sm comma Tk belonging to R cross Z. Similarly, commutativity can be easily shown since R is ring, therefore under addition it is commutative, and similarly Z is commutative under addition since Z is also a ring. Now इसका identity show करने के लिए zero element under addition क्या होगा, r comma n, zero element suppose हम I comma j ले लेते हैं, is equal to r comma n, which in turn implies r plus I n plus j is equal to r comma n, which is equal to r plus I is equal to r, n plus j is equal to n. That is I is equal to 0 and j is equal to 0. Therefore 0 comma 0 is its zero element. And additive inverse देखने के लिए what we will see that r comma n plus minus of r minus of n is equal to 0 comma 0. Therefore minus r minus n is additive inverse, where minus r is inverse of r in capital R and minus n is negative of n in Z. इससे हमें ये तो पता लग गया कि r cross Z is additive abelian group. मल्टीप्लिकेशन में अब जैसे हमने डिफाइन किया है इसमें एसोसिएटिविटी शो करना रह गया बस, एंड obviously unity. Associativity will be very easy to check under the multiplication as we defined, and for unity we will do now. And one more property is there in rings, that is distributive laws. should hold. That is also very easy to check. Associativity कैसे होती है? x डॉट y डॉट z, जैसे हमने इसमें मल्टीप्लिकेशन डिफाइन की है, should be equal to x डॉट y डॉट z. एंड डिस्ट्रीब्यूटिव लॉस कैसे होंगे इसके अंदर? r क्रॉस n s कॉमा m प्लस t कॉमा k is equal to r कॉमा n s कॉमा m प्लस, जैसे हमने मल्टीप्लिकेशन डिफाइन किया इसके अंदर, r कॉमा n प्लस t कॉमा k. डेफिनेशंस अप्लाई करोगे तो ये आ जाएगा. सिमिलरली इफ r कॉमा n प्लस s कॉमा m डॉट t कॉमा k is equal to r कॉमा n डॉट t कॉमा k प्लस s कॉमा m dot t comma k. Hence r cross z forms a ring under the operations we have defined above. With unity अभी हम शो कर देते हैं. r comma n unity हम सपोज कर लेते हैं s comma m है is equal to r comma n. Now जैसे कि इसमें मल्टीप्लिकेशन डिफाइन था, by that it implies r s plus ns plus m r comma nm is equal to r comma n, which in turn implies rs plus ns plus m r is equal to r and nm is equal to n, which in turn implies m is equal to 1. Put 1 here. rs plus ns plus r is equal to r. rs plus ns is equal to 0. S r plus n is equal to 0, which in turn implies s is equal to 0. Therefore 0 comma 1 is the unity of the ring r cross z, and therefore r cross z forms the ring with unity. Now we will show that r can be embedded into r cross z. Define a map phi from r to r cross z such that phi of r is equal to r comma 0. अब हमें सिर्फ क्या शो करना है? That phi is a ring homomorphism and phi is 1 1. Then we can say that it is an embedding map. Well defined शो करने के लिए हम क्या करते हैं? For r equal to s, it implies r comma 0 is equal to s comma 0, which in turn implies phi of r is equal to phi of s. Therefore phi is well defined. And similarly हम reverse चलेंगे that let phi of r is equal to phi of s. It implies r comma 0 is equal to s comma 0, which in turn implies r is equal to s. Therefore phi is 1 1. Now ring homomorphism शो करने के लिए हम क्या करते हैं? Phi of r plus s is equal to r plus s comma 0, which in turn is equal to r comma 0 plus s comma 0, which is equal to phi of r plus phi of s. And now phi of rs is equal to rs comma 0, which in turn implies r comma 0 into s comma 0, which is equal to phi of r and phi of s. Hence phi is a ring homomorphism and phi is 1 1. Therefore phi is an embedding map. Hence we have got that any ring can be embedded into a ring with unity. It was embedding of a ring into a ring of unity. That's all for today. Thank you.